indeed an international context, a multilingual one. We're going to switch to English for the first part of this second session. I welcome you to it. Next to me is sitting Frau. Okay, Frau. Okay, Assistant Professor Paraskevi Giouli. He is a professor of computational linguistics at the University of Thessaloniki in our School of German Language and Literature. She graduated from the National Kapodistrian University of Athens. Her BA was in Greek philology, specializing in linguistics, holds a master's degree from the University of Edinburgh, speech and language processing, and she earned her doctorate in computational linguistics from the National Kapodistrian University of Athens. Her research interests focus on the computational treatment of languages and language technology for human-computer interaction, focusing on morphosyntax, syntax semantics, and the lexicon corpus interface. She has been active in the development of computational tools and resources for natural language processing at various levels of linguistic analysis, and is the scientific coordinator of the Greek team in the Global FrameNet project, co-organizer of the series of competitions for the identification of verbal multi-word expressions, and the results of her research have been published in collective volumes, scientific journals, and proceedings of international conferences. She is a member of scientific organizations, European Association of Lexicography, Association for Computational Linguistics, many. I'm not going to mention all of them, dear Vula. And today, she will focus on educational applications in her presentation titled Mind the Gap, Harnessing LLMs to Build Educational Applications, Friends, Fakes, and the Developers Workbench. Dear Vola, the floor is yours.
Thank you. Thank you, Olga. Thank you all for being here. It's a bit weird today because I think I'm the odd one out here. I'm going to show you the backstage of all the magic that you saw before. So, Mind the Gap, Harnessing LLMs, Large Language Models to Build Educational Applications, Friends, Fakes, and the Developers Workbench. So I am on the other side of the river. I'm going to start with clarifying some misconceptions that are around lately, and then I will briefly go through the history, focusing on the strengths and limitations of AI. My focus here is on the usage of large language models, because behind ChatGPT we have a large language model for building effective applications, and I will briefly present you the current research that is underway in the Department of German Language and Literature of the Aristotle University of Thessaloniki. So, let's start by dispelling some widespread misconceptions. First of all, many people think that ChatGPT is AI. ChatGPT, I'm afraid, is simply an application of a specific type of AI. It is what we call a chatbot, a chatting bot, a bot that is based on a large language model, which is called GPT. GPT is the name of the architecture, the model that is hidden behind chatbot. Notice also that ChatGPT is not the first chatbot. Chatbots have been around since the 60s, believe it or not. And finally, the way that AI is shown seems sometimes that AI can understand language. Can it? We'll see. Okay, so these misconceptions often stem from confusion about core concepts. So the question is, what is AI? AI at its heart is the science of creating machines that can imitate human cognitive behavior. So systems that have the ability to learn, to adapt, and most importantly, machines that learn to solve problems, that are able to solve problems. And what we see in ChatGPT, we have various AI tasks that are well defined and on which researchers from various disciplines have been working for many years. So AI is already all around us, from computer vision, like face identification, systems for emotion recognition from the facial expressions, object recognition, medical imaging, autonomous driving, everything is AI. Other fields are robotics, weather forecasting, music generation, financial technology, and so on and so forth. Of course, speech and language was and still is at the heart of AI and ChatGPT and those models. So we have technologies like speech to text, taking speech waves and transforming them to textual data, and the other way around, text to speech, are well-defined technologies. Natural language understanding, natural language generation, machine translation are some other instances of what AI has been all these years. So, natural language processing is a particular vibrant branch of AI. It encompasses tasks like machine translations among various language pairs, including sign languages, information extraction, information retrieval, question answering. Those technologies have already been implemented and integrated into ChatGPT and similar chatbots. Automatic indexing of large archives, automatic document summarization, also multilingual and multimodal one. This means that we are now able to take not only texts in various languages, but also other means of information, videos, pictures, and so on and so forth, and we can create summaries of those multimodal sources. Text simplification is another technology. The identification of sentiments expressed in text and opinion mining is another mature technology. Toxic and hate speech detection, misinformation and propaganda detection, and conversational agents and personal digital assistants. Such technologies you can encounter in chatbots and technologies like ChatGPT. So, in order to understand how this discipline evolved, we need to have a look at the AI at a glance. The idea of a machine that thinks dates back to ancient Greece, of course. But it was only since the advent of electronic computing that this idea started to take on flesh. It was in 1950 when Alan Turing, the father of computer science, published what is called Turing test. It was a way of testing a machine's intelligence. It is called the imitation game, which some of you might have attended in the film imitation game. So the idea is to find a way to make machines act like humans by making them imitating what humans do. So the idea is that we have an interrogator. The interrogator is on one side, and then you have a computer, a machine, and a human being. The interrogator makes questions, and then a machine is intelligent only when the machine and the human respondent respond by using text. So the machine is intelligent only when the interviewer, the interrogator, cannot distinguish between the responses that the two are giving. 4 years later, the Georgetown IBM experiment on machine translation showed the ability of machines to translate. So it was the first instance of machine translation. 2 languages. Can anyone guess what these languages could be? Anyone? Russian to English. So it's Cold War. Bear in mind that AI has evolved according to policies, according to politics, and according to what, for example, US or the European Union wish to develop. And this could probably be the topic of another presentation, but this explains mainly why US and China have AI. They have those foundational models, whereas Europe only has AI Act. We have laws about AI. The first chatbots appeared in 1966. It was Eliza. It was a chatbot that was mimicking a psychotherapist. And a few years later, we had Pari from Paranoia. It was a chatbot that was trying to mimic the language of paranoid people. Later on, we had, in 1980, the philosopher John Searle published a paper explaining how machines work. It was a response to Turing tests. He actually said that machines are not intelligent. In fact, what is intelligent is the way that we give them information. So it is a matter of input and output. And it was later on, in 1990, that computers started to have more capacity, more computing capacity. Remember, the first computers, when this discipline started, were big enough, but their computational capacity was really limited. So it was only after 1990 that we had really huge data in machines, and machine learning started. And then we had those wonderful things that are called neural networks. These are tools that try to mimic the way, they are artificial neural networks, and they try to mimic the way neurons in our brains work. And from there, the machine learning tsunami started. Later on, we had, from 2009, we had AI in everyday applications like Alexa and Siri. And in the last decade, we had the advent of the new so-called large language models. GPT is a large language model, and on this model, ChatGPT is based on. And before GPT, we had Elmo, and many others appeared, some of which have the names of Muppets, as you can see. So this is mainly the history of AI. You can see that AI did not start when ChatGPT appeared. So we have been working on various applications, on various technologies that are now integrated into ChatGPT. And as I said, our workbenches are always related with the capacity of computers. When this discipline started, linguists were developing expert systems with predefined rules. So we, computation linguists, had to manually craft those rules. And then as we had more powerful machines, machine learning started, and we had the ability to perform statistical pattern recognition. Deep learning changed the scene. As I said before, it was the deep learning tsunami, and now we have massive transformer models, which I will present now. I promise this is the only technical slide that I have here, but I just want you to somehow grasp how this works. So we have, each time that we input a prompt or a question to the system performs an elaborate organization. It tries, the computers don't know what language is, what words are, what phrases are. The system tries to tokenize, to identify small chunks of language. So they are performing these elaborate tokenizations. They try to split what we are writing. Then computers don't know about words, they don't know the meaning of words. So what they are actually doing, they are trying to represent words as vectors. Don't bother, I don't expect you to understand what vectors are, but simply put, vectors are arithmetic representations. They are simple numbers. But how are they computed? They are computed based on Harris-Zelling. Harris-Zelling was a famous linguist who defined what we call, and many of you might remember that, what we call distributional semantics, distributional grammar. And later on, Firth said that you shall know a word by the company it keeps. So based on those linguistic notions, engineers try to represent languages depending on their similarities, their proximities to other words. So in essence, words that have similar meanings have similar numbers. So this is how the computer understands synonyms or other types of words. So this is not magic. It is grounded on linguistic theory, and it is then converted into mathematics. And what the system does is it tries to compute statistics and probabilities of the occurrence of words, numbers in essence, in certain contexts. So the problem is called a masking problem. The system tries to predict the following word based on the proximity, based on the items that are in the proximity of this word. So if you have the sentence, Paris is the masked word of France, then words like capital, heart, center, city are very close to, very similar words. So the system will bring you those words that have the same distribution. So this, as I said, this was my only technical slide, so I'm moving on. So LLMs are trained on billions of data from various sources. They are fed with data. So in our discipline, data, which is only data, are important. So LLMs are trained, they are fed with essentially what exists on the internet. And that's why they are capable of computing those similarities and those probabilities that I talked to you about before. And so they are capable of generating language based on those probabilities. So actually, it's not magic, it's generation. So that's why we call this type of artificial intelligence generative AI, generative artificial intelligence. So As you have seen, LLMs do not understand language. They just predict tokens without understanding meaning. So, as Emily Benter and her colleagues stated in a paper that was published back in 2021, LLMs are simply stochastic parrots. And stochastic means here parrots that use probabilities. So, since they have been trained, those foundational models have been trained on essentially whatever exists on the internet, they are too general. And as you might imagine, less resource languages, languages which are not that big like English or even German. German is not equally resourced as English, but it is a well-resourced language. Greek is a medium resource language, but there exist because we are in the EU, and EU has funded many projects to produce data for language technology. So imagine that there are many other languages which are under-resourced or unresourced, and language varieties. And then there are some phenomena that are not modeled in those models. Idiomatic language is part of it. And also, the data are not clean. Whatever exists on the internet has been used to train those machines. So all sorts of biases exist. And of course, since the system does not use knowledge, but generates language, then we have this phenomenon of hallucinations. So large language models just hallucinate. So what do we need to do? What we need to do is take large language models, which are trained on massive unlabeled data, and all we need to do is fine-tune, try to make them know the domain that they will be used for. So once you have your large language model, the foundation model, either GPT, Gemini, BERT, Llama, or all those that exist, then all you need to do is to feed this model with new quality data. And then you will have software as a service that has been trained on this data. So, fine-tuning means collect data that are appropriate for specific tasks, clean them and annotating them, and then feed to the system. And once you validate, then you're sure that your system will perform correctly. And if the validation is not good enough, the result of the validation, the performance is not good enough, then you continue to collect data, clean and annotate, and so on and so forth. So this brings me to the research that is underway in our department. The project is called Emobot. It is going to be an intelligent tutor for language learning with emotional intelligence. So it's a funded research project aimed at leveraging LLMs to develop a bot for learning German as second language. The target group is users with Greek as their first language, the mother tongue, and it's going to incorporate emotional intelligence using cues from various modalities. And it also takes AI ethics into account. Our principles are that our research and the outcome will be human-centered. The idea is to support people, not replace teachers, to avoid bias and discrimination. So we're going to integrate a system, a model that identifies bias and toxic language. We're going to account for privacy and security, and of course, we want to provide explainability. The foundation models, we don't know how they are trained, so explainability is an issue here at stake. So the outcome will be not only a system but also, as I said, we want to account for explainability, how those systems work, and also a byproduct will be quality language resources. Language resources, as I said, data are important for our domain. We're going to develop a several-level educational corpus of German, a learner corpus, and a specific lexicon of constructions, and a model for toxic speech detection. So, 2 universities and 2 companies, and here you can see some of the core research team. So, these are our takeaways. Thank you.
We thank you as well. We do have 2 or 3 minutes for questions, comments. Okay, I'll start and then you will get warmed up, yes? Okay, let me just say that if I wanted to link your presentation with Professor Strauss's presentation, I think one possibly could argue, but you will tell me if I'm right, that the stereotypes we saw in the videos and pictures about, okay, so I'm right, but I will say it anyway. It's not that, because the input is from the internet, whatever is out there is being fed. That's how the stereotypes tend to keep existing, right?
Yes, yes. Imagine that what's there in the internet depends on who has access to the internet, who is able to provide data on Facebook and all those social media. So essentially, I was in a conference and people said that it is what the medium class male white man thinks. So when we first, I've been working in research for many years, so when we were trying to build the first Greek LLM, Meltemi, we were doing some research on ChatGPT, and we asked questions, we prompted ChatGPT, and when we asked about Sakelloropoulou, the system said, no, you cannot have a woman president because women are not usually. So it is what the system was fed with. Okay, and if I may, a connection is when you have those wonderful technologies, those technologies are the product of trying to link bits and bytes. The technology where you have the person talking in German, but then the voice be in Greek, you have 3 technologies in there. You have speech to text, then machine translation, and then again text to speech. So I think that I have ruined the magic here.
So, questions, comments? You're not warmed up yet. Yes.
Thank you very much for your presentation. I would like to ask you, your AI application is called eBot. How it wasn't really clear to me. What does this application has to do with emotion? I understand that the word is a compound word, emotion in bot. How can is it in any way related to emotion? Can this could this application have something to do not with just language analysis or processing, also with some way having processed to human emotional intelligence?
Okay. Thank you for the question. Yes. As I said, we are two universities, Aristotle University and Piraeus University. They are experts in emotional recognition from facial expressions and other modalities. So what the system will do, it will try to identify the emotion of a student. That could be anxiety or indifference for what is going on, and then we will try to find ways so that the system responds with emotional intelligence. That is, try to encourage the student and try to make it have emotional intelligence.
Last one for you, Irene.
Thank you. Thank you very much for the presentation. It was very interesting, especially how we got here with the AI outcome and historical view. My question is eMobat accessible to the public or still not?
Well, the project is at its initial steps. We're just starting. So when it is finalized, then it's going to be available. As a matter of fact, all the resources, even the linguistic ones, will be available for research. We hope that this will be the beginning of building an infrastructure for teaching and learning in German, tailored to the needs of the Greek students.
Thank you so much, Professor Giouli. Thank you.